Hey robot makers, hope you're having a good day so far. So just to learn about how to make your own Pico plotter, program it in MicroPython and read G code to draw absolutely anything, then this is the show for you. So let's dive straight in. My name is Kevin. Come with me as we build robots, bring them to life with code and have a whole load of fun along the way. Okay, let's get over to my keynote and we can walk through a couple of slides I prepared for you. So previously last week we looked at putting together that kind of minimum viable product for this project. So version 1 was a simple XY pen based plotter. It could make the pen go up and down. We could use a simple 3D printer to print out the parts for this, and we could control it with a Raspberry Pi Pico using MicroPython, and it'd be able to read in G code, which is this kind of Gerbil language, and be able to accept commands and do all kinds of stuff. So version 2 of this would have end stops so that we could actually home the plotter automatically, and version 3 and 4 would have like an SD card reader and a web interface. So where are we up to this week? Let's have a look where we've got up to. So I did an entire redesign of this original model. So this original model, if I just grab this one, this was by somebody called Daz Projects. If you go to like Thingiverse or Printables, I think this project is available now. It's on last week's show notes if you're interested in that particular model. I created a little holder for some of these motor drivers as well. But it's very, very simple kind of design. You've got a gantry, you've got these tooth gears, and you've got the stepper motors controlling them. So let me show you how I've reworked this design somewhat. So I recreated the entire project in Fusion 360, and this means that I could then test out some changes that I wanted to make. So one of the first things I wanted to make was to add these little micro switches, which mean that we can have some end stops. So the gantry would move along to a particular point, it would push against the little micro switch, and that would click, and we would be able to detect that that switch has been pressed. And that means that we can find the origin point very easily and make our code do this automatically. So I've added some little areas, we'll have a look at those in a second, to find that homing position. I've also made some other changes as well, but because I was recreating this completely from scratch in Fusion 360, it did mean that I had to do an awful lot of test prints. So rather than printing out like the entire piece such as this, where the entire length of it is about 190 millimeters long, don't know why it's that specific length, but that's what it is. I created these tiny little pieces instead. So that's kind of a cross section of that longer piece. And then what I then did was I just printed out a little block. So this is like a smaller version of the toothed rail that's going to go on it. So this very first one, now although this looks like it's correct in Fusion 360, I cannot get this to slide into this piece. So what's happening here is it's probably too high in this kind of orientation. I can get that against my black t-shirt there, and it's also probably a bit too wide. So the next print that I did, I made it ever so slightly more tolerance, and again this doesn't slide in nicely at all. We can kind of wedge it in, but we need it to be really friction free. I then did another version. This one is getting better, so this one doesn't slide in, but again loads of friction required to push this in, and we need this to move very, very smoothly. So in fact I'm struggling to get that back out now. And then finally I came across the ultimate tolerance that I needed for this, which I think was 0.1 of a millimeter, might have even been 1 millimeter. So I'll share the files very, very shortly. But yes, this one moves nicely. So this has got the correct tolerances, and this is what I built the model around. I also reworked the pen holder. So the original pen holder wouldn't be able to hold a Sharpie. I got the Sharpie to hand. I think this is my reworked version. So my reworked version, you can put a Sharpie in. Sharpies tend to have this little area here that you can use as kind of a stop. So the version that I've now reworked, the one that's actually fitted to the plotter, has like the perfect tolerances for your average Sharpie pen. There's the black pen that I've been using for this entire project. So there we go. So this particular version doesn't work with these sort of fatter Sharpies. So it's just like a regular Sharpie. I think the other one was a fine liner, so it's ever so slightly different. So the regular permanent marker Sharpie size is the one that I've gone for there. What else I've got on here? So yes, these little areas for these end stops, and just had to recreate the entire model from scratch in Fusion 360. So that probably took me about 2 days to do that and test print all the different pieces. So I've actually been through quite a few iterations. I've got this piece here, for example, and on this one, when you have the tooth rails in, and you've got the little gears in as well, although this looks correct in Fusion 360, the distance between the tooth gears and the tooth rail mean that it's like really, really wedging in there and can't spin freely, and therefore the stepper motors just can't provide enough power to move the rail around. So I had to reprint these and work out different tolerances on them as well. And one of the questions that came up in the chat just as we were going live then was, did I figure out what the short circuit was? So last week we had all this wired up and it was registering that there was a short circuit in the circuit somewhere. And I found out what that was, and I also found out why the pen mechanism wasn't working. Let's see if I've actually got the... so this is probably the one that's shorting out. So when I originally designed the pen holder, that little hole in it there that you push onto the stepper motor, I actually used some mole grips to squish this on. I basically just did that and crushed it like that to make it fit nicely. I didn't realise by crushing it, it would actually compact all the electronics inside. I mean, I don't know why I didn't think. I think it's because it's made of metal, but it's only a very, very thin piece of metal. In fact, you can quite easily take these apart to see what's actually inside them. I did this one previously. I'll just take this one apart and show you kind of what's inside one of these servos. But it's essentially a package of very closely. There we go. So I've just popped the cap off that one. So you've got a bunch of little gears inside there. Let me go full screen on this for a second. You've got a bunch of little gears inside there, and there is also like the main gear that's sort of poking out the top there. So we pull all those little gears out. If I just they're loosely just fitted onto the top. So I'm just like popping these out. There's about 5 of them. There we go. And then I'm going to show you the innards of this. So there we go. All the things are off there. We've got this kind of plastic piece on here that just connects. If I just remove that as well, just in case you've never seen inside one of these, they're quite interesting to see what's in them. So inside this plastic piece, there's just like a little circuit board, and it's very, very crude. It's just connecting up several pieces of copper. So let me just pop out this piece. Just trying to find the best way to do that. So if I just take out this here, we're now getting into the sort of very innards of this, and there's only just this one last piece to come out. Let me move that up. They're not held in particularly tightly, these either. And then that's the inside of that piece with that removed. So that's actually a piece of plastic. That plastic is, let me just move this out. See if I can actually get this last piece out. They're just ever so slightly wedged in there. There's little pieces of metal that are designed to keep everything in place. Right, it's probably wedged up enough now you can actually see, if I get that in focus there. So you can see there's actually 2 kind of copper turnings, and they're separated by these pieces of plastic, and then there's metal inside of them as well. There we go. Pop that out entirely. So you can now see what's inside there. So that's how the that sort of tooth thing is just how they're sat there. So you can actually wedge these apart, and you can see exactly how this stepper motor actually works inside. So it's simply just 2 pieces of metal separating them with pieces of plastic to separate them. So by crushing these all together, that's essentially made pieces that don't normally touch, and it also stopped that from working properly. Not 100%, and that's the weird thing. It didn't sort of short out the entire circuitry, it just meant that it didn't work properly. So that's kind of what's inside one of those little 28 BYJ stepper motors, just out of interest. So by not squashing them on, by making these fit very, very loosely, and just using a bit of super glue to secure them, that worked wonders. So yeah, 2 entire days to reprint and redesign this, so that I could then play around with the all the different parameters of it. So this is the new base. You can see I've got the micro switch mounts on the very top right over there, that little tab that's sticking out there. That is for the micro switches. And we've also got the Pico plotter nameplate on there as well, because why not? So the tooth rail, I did a video on Wednesday showing you how to do these toothed rail pieces using Fusion 360. So how you do rack and pinion, really, really simple to do in Fusion 360. So there's a nice little video showing you exactly how to do that on there. And again, I've test fitted these with these little pieces for tolerance, just to make sure everything fits nicely and moves smoothly. This is the reason I've got this spare one. Where's that coming off there? Spare one top end. This piece here had the wrong tolerances for the little gear, so that's why this entire piece is now spare. So that's the tooth rail. We then have the little cog gears themselves. Again, I printed out. These were really quick to print, like 5 minutes or something like that. So you can see the profile there of the inner piece that the servo motor connects into, stepper motor. So I printed out quite a few of these with like different sizes of inside. You can see that one is all these two up together. You can hopefully see that there's one's on the right small and one on the left is much larger. And I've got the right size, just about the right size. And again, you just apply a bit of super glue when you're putting these in place. Really only on the pen holder is that required. So looser fit, no squash required on the no crushing with mole grips required to put these on now. Then we have the Y tooth rail, so that one has another holder for the pen mechanism. So that's got that sort of a half moon shape on there. And we've also added the end stop. There's like a little piece that just sticks out just here, and that just helps the end stop find the end of that. And then the stepper motors themselves, so I actually modelled these up in Fusion 360. They're quite an interesting shape. Where the spindle comes out, unlike other motors, it isn't central because of all these sort of gears pieces. It kind of comes out at the side. It's 8mm from the very central point to the central point of that spindle. But by modelling it in Fusion 360, that means I can check for the fit and finish, make sure everything fits together nicely, in theory. Then there's the Y gantry, so that one looks very similar to the base one. So this is the base that I've got here. It's got the Pico plotter name on it. This one kind of just goes at a right angle to it. And again, you can see what the end stop there, and test fitted that for the fit. And on the very end of that, there's two little holes there, and that's so that we can put this little roller in. The roller, if I show you on the original one, the roller is this piece here, and it's just like a little wheel with a little M3 bolt on it, and that means that you can it holds it the right distance of the paper. So as you're sort of looking at this, that's the sort of plane where it's going to sit on top of the paper. And then the micro switches, so I modelled those up as well. I think these are pretty standard, these micro switches. I'll show you the model I've got here. They've got these nice red sort of backs to them. But yeah, they're very, very similar kind of a standard kind of size, I think. So Y1561C25. You can see that the voltage rate is like pretty high, but that's really all we're interested in. You've got like a normally open, normally closed, and then the ground. So you can choose, you want to have this kind of always open and you press it and it makes it a 0, or do you want it when you press it, it gives you a 1. And that's what these two different connectors on there are for. I also used these spade connectors. I'll push these on and then show you it. So spade connectors, I've not come across these before. Just need to hide my face there. These little pieces of connectors, and they simply just push onto our micro switches to make a nice solid connection. And you can simply just crush, using a special tool, your cable onto them, so it's not even any soldering required to make a really solid connection. I needed these because you can see this one, I soldered this one and it kept disconnecting. For whatever reason, the solder kept ripping off on there. So even though these are on quite well, they've gone through the hole. You know, I've stripped the wire up, put the wire through the hole, solder it, and it would still rip out. And I found that these spade connectors worked much better as a connection. So there we go. And then of course I modelled a Sharpie. So again, a very interesting shape of Sharpie to model them. I did think about putting like Kev's Robot Sharpie as some kind of a font, and I thought that's probably too far. Let's not go overboard on that. but it did mean that I could measure the distance between the tip and that kind of stepped piece just there, and that means that we can then accurately, I can show you that stepped piece that's just where the black piece stops, and that means when we push that through that thing there, let's get that to screw kind of in there, it stops and holds it. And I need to make sure that the paper, where the pen touches the paper, the height of that is consistent across, so that we don't need to have the pen at a sort of wonky angle. So that's the Sharpie modelled as well. Then the pen holder, yes, the pen holder, I redid this one so that I didn't need to crush, and essentially it's that little piece where it makes connection with the stepper motor. I just made that a little bit looser, and therefore we can just super glue that on. So it's got regular kind of super glue. I can use the Gorilla super glue for that one. And yes, the roller. I even had to redesign the roller and the little wheel as well that goes with that. So there's the little wheel as well. So assembling this together is pretty straightforward. I did these slides for the website, but I'll just quickly whiz through these. So we simply just slide this toothed rail into the base. There's a nice little slot. When you first 3D print this, there's all kinds of support materials on there. So when you push it through the first time, you might find there's a little bit of friction. But if you work it through a couple of times, you'll find that it's really, really smooth. So it's designed to be a nice smooth finish on there, nice friction free. Then you place the cog into the tooth rail. There's nowhere for it to connect to, and you just sit it on there first of all. So you just get your little cog, you just sit it into the tooth rail, and then you might need to move the tooth rail to sort of spin this round so that that little slot shape matches where the stepper motor is for the next thing, is where we put the stepper motor into that little hole, just like that. I've used wood screws for this. Let me show you what these look like. These are tiny little screws. These are M3. These are quite short. I'm guessing they're about 10 millimeters, a centimeter in height. Let's just measure that. Yes, it's pretty much 1 centimeter, but they're M3 size. So these ones have got this nice point on it, and they really grip into. I'll show you on this test piece here. Have I got a screwdriver to hand? Maybe just use this one. So if I show you on this here, when I screw this in, we get a really nice grip. Now, because it's screwing into the plastic, there's only so many times you can unscrew this, so yeah, you really don't want to be screwing and unscrewing this too many times, but they're designed to be just kind of screwed in once, and you get a really nice solid connection there. So you need to make sure you rotate that cog, like I said, to make sure that the stepper motor is aligned with the spindle hole. But the stepper motor's got the holes in it for the mounting, and we're simply going to drop those into place, like the diagram shows you there. Screw them in with the wood screws. Then we have the where the gantry, the top gantry kind of goes at an L kind of position. Kind of like that kind of position, where this goes on top of the toothed rail. There's 2 little holes that you can align, and then you can screw it in place. But I found that putting super glue on there makes it like a really, really solid connection. You only need the tiniest amount of super glue, and then just clamp that for a couple of seconds for it to make a good join. Again, the wood screws I use for that are these tiny little 1 centimeter M3 ones. And you will need to make sure you screw them really, really flush so that that tooth rail can pass over it without getting jammed on the top. So that little hole just there, you could probably leave out that screw, to be honest, or unscrew that when you've finished putting this together. Okay, then we have the tooth rail itself. So this is the Y tooth rail. This is the top one. This one has the pen holder piece on it. It has that sort of half moon shape on it just there. Should slide in, no friction at all there. And then we have the little cog that goes on the top there. Again, it sits in between those 2 mounting points. It's not sat on anything, it's just sat on the surface there. And then when you put the stepper motor on top, the stepper motor little slot should find that little hole just there. You can then fit that in with 2 of those wood screws. Then we put the stepper motor on the top. Just need to rotate it round, or pull this back to sort of rotate the cog a little bit, just so it finds and aligns with that slot on the stepper motor. And then the pen stepper, that just pushes into place, nice and simple. Again, we hold that in place with more of those wood screws. And then finally we put the pen holder onto there. So I do use a simple spot of super glue just inside the end of this before you put it onto the stepper motor. Just make sure that it can rotate round and you're not gluing the stepper motor either to the rail or to the make sure it can rotate round and you're not gluing that in place, is what I'm trying to say. So we just want to glue this pen holder to the little brass fixture that comes through there. Okay, and then we've got the roller and the little wheel. So there's the roller, we simply screw that in with 2 of those wood screws again on the top. You could super glue that in place, to be honest. And then the little wheel goes there, and then I use an M3 nut and bolt to pass through there. So I can show you that on this version I've got just here. You can see there's like a little nut and bolt holding that in place there. Then the micro switches. So this is the new addition to my version of this. So these simply drop in place, again nut and bolt through the top and bottom to hold it in place. And then connectivity wise with cables, I think these spade connectors are the way to go. You might find that your soldering is much better than mine and you can use that without any issues, but I found that this was the way to go. So just the regular spade connectors for that works fine. And then on the other side there's another micro switch. So I'm only using 2 micro switches currently. I might change my mind and put a third one on for the pen, but because we're only moving the pen up and down, we can actually just make sure that our code always returns the pen to an up position, ready for the next command. So at the end of a job or the end of any code running, it can just return to that, and therefore we know that it's right. We can just assume that it's in the right position. These stepper motors use lots of gears inside, so they don't automatically fall or roll around. They kind of keep their position. So yeah, note that the micro switch arm should point towards the wide tooth rail stepper motor. So it's just the direction that you want the stepper motor thing to be. You want to make sure when it rolls up against it, it does actually close it. You can actually bend these a little bit if you need to, just to make sure it gets a good fit. And then finally we've got the Sharpie. So the Sharpie should be a really tight fit to make sure the pen makes contact with the paper and doesn't sort of move out. It should be a really good fit. If you find that you printed yours and the fit means that the Sharpie sort of, when it touches the paper, it kind of like pushes out a little bit, you can just use a little bit of blue tack, this kind of white tack, blue tack stuff. Just put a tiny piece of that inside when you're kind of screwing the Sharpie into place there. So, and the other thing is, make sure that you remove the Sharpie once you're finished working with this and you put the lid back on. If you don't do that, you end up doing what I did. So this Sharpie pen that I've been using as my prototype, it looks like it's stopped working. It's essentially just dried out. So I think I can probably bring that one back to life, just with a bit of like rubbing alcohol just on the just let that soak through, and it should probably make it work again. Okay. So let me just go back over to my notes there. So, improvements I made since the previous design. So obviously we've talked about the step motors, the micro switches even. So the distance between the gear and the rack, I've adjusted that for the real world printing tolerances. So I did actually have this entire one printed out, and I found that the stepper motor kept missing steps, and it was because it was basically pushing this too tightly against the rail, and that's because the centre of it needed a bit more tolerance. So I've reprinted out this entire piece with about a millimeters difference, and that seems to have made all the difference. So the cogs have all been tested for fit and finish as well, and I've adjusted both the cogs and the position on the gantry to make sure they work properly. So that cog spacing is something I've been working on. This is why it's taken 60 hours this past week to work on this project. So I've also allowed for easy homing and reset for each drawing, so you can simply just issue the $H command and it will home the plotter. Really, really satisfying seeing it do that. Very simple to add to our model and also to our code as well. I'll show you how we do that in the code in a minute. Spade connectors, so yes, I've talked about those on the so I've not got a picture there to show you, but you can just see on video next to me there. They make for a really nice connection, very easy to use, solderless, and it just means the micro switches and the Pico have that really solid connection there, crimping both ends to secure them in place. And this code definitely now works with CNC.js, so we can get this to draw something. We'll try that in the demo in a minute. I think there might be a tiny bug in my code still, but I've just tested it by hand and it works. So let's see if we can get our G code to work properly in a minute. And yes, we had a short circuit last week, and like I said, that was caused by me crushing the pen holder in place with my mole grip. So I don't know if you've seen these mole grips before. You can sort of tighten that grip and then you can apply a lot of force with one of these. And I was just using it to sort of just put this pen holder onto the stepper motor, and yeah, crushed all the innards, and that's where the short circuit was occurring from. So now as I look at my my bench power supply, I'm not getting any short circuits, and it's working much better. I'm going to say perfectly, working much better. So MicroPython wise, I've redesigned the code in that. I'm going to talk to you a little bit about vibe coding. So on this project, I thought I would try, rather than just writing everything from scratch, I would use ChatGPT to help me create this code and just see how that works out. So it's really quick to get started. It will give you really good code that does work, you know, right from the get-go. And it's kind of conversational style of coding. So you'll say, you know, that works fine. It might say, would you like these extra features adding? You'll say, yeah, sure, add those features, and it'll change your code as you go. Now, it's very easy for your code then to become fragmented or confusing, and I found sometimes you have to cut and paste the entire code you've written back into ChatGPT, even though it's generated it for you, and it'll go, ah, right, I can see that what the problem is now. And it's like, yeah, but you told me that. So unless you're a good coder to begin with, you can end up making code that doesn't work after only a couple of improvements on there. So it might produce code with missing parts or doesn't do what you expect it. And if you can't articulate to ChatGPT how you want this to work, then you know it might not be the way for you. But I know quite a lot of developers do use this style of coding now. I would say it's probably not the way to go if you're a beginner. You'll end up creating code that you don't understand and don't really know how to fix. So let me know, have you done any vibe coding, as they call it? If you're interested in that, I can do that in the live demo, just to show you the kind of how you know what the workflow looks like and the kind of code that it can spit out. So let me know if you're interested in that, and we'll definitely look at that as well. If you like these videos and want me to make more of these kinds of videos, then drop me a like on this video. Let me know in the comments if you've done any vibe coding yourself. That's the interesting question for today. And if you've not subscribed to the channel, please subscribe. It means so much to me when people subscribe. And it's the time of the year where it's summer, people are outside, they're watching less and less YouTube videos, so I get less subscribers over the summer period, but they all come back in when it starts getting colder outside. So there we go. I can see all the likes coming through there. Thanks everyone for that. I do go live every single Sunday at 7 o'clock British summertime, or GMT when it's in the winter months, so you can come and have a chat and interact with me on the show. I always enjoy when people do that. We've got quite a few people watching live right now as well. Right, let's get over to our Pico plotter. So what I'm going to do, I'm just going to put it on me for a second. I'm going to get my show notes up on my other monitor over here, and I'm going to show you kind of, yes, this plotter actually working. So I've got it all set up over here. You can kind of see the electronics there. So there's the Raspberry Pi Pico that's got all the connections. We have, these are kind of just loose at the moment, so I do need to rethink how they're going to be sort of stored. On the previous model, if I just bring this across for a second, I did have this little thing for just keeping everything in one place. The cables are actually quite short on the stepper motors, so that means when you're at the extremes of the plotting area, that it can be sort of stretched out, and that can be a bit of an issue. So one of the little models I designed to house the Raspberry Pi Pico for this project was just like a little crate. There were these toys in the 80s when I was growing up called Starcom, and they had these little sort of cargo boxes, and I always really liked them. So this one, let's open this back up, a screwdriver in there to let me do that. So this is just all friction fit. You can see there we've got the Pico, and it can go in there sort of upside down with its pins all facing upwards, and then we've got some holes in there for the pins to go through. So that's kind of what I'm thinking there. And we've got where the Pico has its USB connection, we've got a little hole so that we can access that through there as well. So kind of thinking like something like that to house the Pico and some of the wires in there as well. Okay, so I have got this set up now, and we have got all the pins and everything connected. I've got a pen on there which looks good as well, and I've got a piece of paper to stop my desk getting sort of messed up. So yes, I've shown you the reason I've gone with those stepper motors with the spade connectors on the micro switches. So where's that gone? That one there. So this piece that I originally had, like I said, these kept snapping, so that's why I've gone with these spade connectors rather than just raw soldering them on there. So that's that piece, and we talked about crushing the stepper motor with the mole grips as well. So yeah, just wanted to explain why we had that short. So interestingly, that stepper motor that I took apart there, you can see that a bit clearer there. I think by crushing the stepper motor somewhat, it might have made some connection between this upper and lower level maybe that it shouldn't do. Not sure. Looks weird, doesn't it? Because there isn't a lot of like mechanical stuff in there. The very bottom of where this kind of sits inside, there is like a little spindle, and I'm guessing that's got some magnets in it maybe, or at least some pieces of metal in there to attract it one way or another. But yeah, there's the stepper motor innards, just in case you've not seen one of those before. You know, a couple of pounds to destroy there, but hey, I did it anyway. Right, okay, so the first thing I'm going to do, I'm going to grab my my code, and I'm going to just split the screen up like this so you can see kind of the code that I'm running and also what it's doing there. So currently the pen is kind of in its up position. So I've got these two pieces of code, pen up and pen down. I simply saved them as pen up and pen down on Thonny because I found I was doing this quite a lot. So there's my pen up and pen down functions. One of them has a pen stop. I think they should both have that. So the stop function basically stops it from drawing any current after it's finished doing its move operation. If you don't have the stop, it can still be drawing current and they get quite warm, which isn't great. Means you kind of wasting power unnecessarily as well. We've also got this full and half full. So one of our viewers, Martin, pointed out last time that I was using half sequences. So this is the sequence that the stepper motors have to go through to energize each of the coils. So you go 1, 1, 1, 0, 0, 0, 1, and this is called a half sequence. The full sequence is simply just without these middle ones in there. So it's much shorter, there's less of them to go through, and therefore they're slightly quicker. I wouldn't say twice as quick, surprisingly, but it's definitely quicker, and you do get more torque, you get a lot more power by using this full. So I've left in the half sequence and the full sequence, and there's a little piece of code in here which is lets you choose whether you want the full or set the step mode. So it's either full or half, depending whether you set it. So that's kind of what that's about there. So if I now set my pen to down, if I'm going to go to this pen down code here, so in the pen down one, so we're just importing the stepper from my stepper motor library, importing time and sleep. We're creating a pen, which is just a stepper motor. It's connected to pins 8, 9, 10 and 11, and we're setting the mode to full, so it's got that full stepper thing. I've left in both of the functions even though we're just doing pen down. Originally I was just testing out to see would it make the pen go up and down, but it's got a really nice motion to it. If I just run this code, there we go, the pen is now touching the paper. If I go to that view there, you can see that it's actually touching the paper. If I move the paper underneath it, you can see that it's sort of drawing there. And if I now run the other code, which is pen up, if I just run that, it's going to lift the pen off the page. You can do that from here. So I can make the pen go down with this code here, and I can make the pen go back up with this same code here. It's simply just doing pen up, pen down, and it's just basically moving the pen 45 steps in one direction or the other direction. So -1 or 1 for the direction. It just makes the stepper motor move. I don't know why 45 steps. We could probably have a lot less than that. We don't need the pen to move that much. It just needs to move, if it's on the paper, we just need to move out the way. And it's just how much out the way do we need it to be, so it's clearly not going to mark the paper. So that's the pen up, pen down. The next thing then I can show you, so I've made all kinds of improvements. So let me do testing the end stops. So this was me simply just pressing the button of the end stop and seeing, do we get a 1 or a 0, pin 12 and pin 16. They're the very bottom pins on the Pico, just either side. So they're the ones I'm using for my my micro switches, and we're using the pull up, I think, in here as well. So yeah, if it's pressed, then we just say button pressed. I've just got this count just so I can see when I'm running this code. If I do that, you can see there, button A is currently pressed. Oops, sorry, I didn't mean to do that. Button A is currently pressed. Sorry, why is that decided to come up there? Let me just go back to Thonny. Why has Thonny decided to stop working? Let me just go back to me for a second. I shall press Thonny. Is it because it's running? Oh no, I can see what's happened. It's just gone off the screen. I've got two screens, like one underneath and one on the top. And if you just move it ever so slightly onto the bottom edge of the other one, which my monitor is obscuring, then I couldn't actually see what was going on there. There we go. Right, back on there. So yes, you can see button is pressed, and that's because currently it's homed on one of the axes, and that's why it looks like it's being pressed. So I'm just going to stop that from running. That's my just testing the end stops work. We can test out homing. So to test out the homing, we need to move the gantry a little bit. So I've got this jog left and jog up code, and this is simply just going to move it 100 units in one direction. So, and we've got the end stop pin on there, and I've also got the end stop direction. So for our code to work, when the gantry is moving either left or right, we're only really interested in the end stop when it's moving in one particular direction. So in this case, when it's moving left, we want to be making sure that if that end stop gets pressed, that we stop any more steps in that direction. If it's moving to the right, we really don't care. There isn't another end stop on the right hand side. It's only if we're moving in the direction of the end stop. So by passing that in as a parameter, we could potentially flip this design or have it using a different direction or something. If we put the stepper motors in the other way round, for example, we could very easily change this code just by making that a -1. So the end stop pin 16 or 12 is what we're using for our end stops, and this is the X motor, which is on pin 0, 1, 2 and 3. So if I run this code, it's trying to go towards the end stop, so I'm just going to change that to -1 there, for example. I can hear it churning away, and let's now change the direction of that to be like that, and you can see it's moving the gantry to the left there. And if I change that direction again, like so, there we go. And have I got that? I've got that in the wrong direction there, so let me just move that backwards a little bit. I think as well, the end stop that I've got on that axis just needs a little bit of bending out, so I'm just going to bend that with my hand a little bit, just so that it makes a really good connection. It's probably a little tweak that I just need to make to the model there. Right, so if I run this again, let me do that in the positive direction now, so it's going to go to the right. As you're kind of looking down on this, that's left, and oops, that direction is right. So what it should do now is it should click on that end stop, which is not quite doing. There you go. So it now won't run the code because it's clicked. If I just do that again, move it to the left a little bit, I'm just going to physically bend that pin a bit more. So it's just got a little bit more of a bend to it. Right, so let me run that again. Okay, let's go in the positive direction now, and what should happen is when it hits that switch, it now stops running, and we actually get a message in the little terminal there saying end stop triggered. Let's move that up there. End stop triggered, stopping movement. So it won't run any more steps. So that's great. So that means we can find the kind of, you know, end stop position. So I'm just going to move that so it's not actually connected on there, and I'm going to do the same with the Y, which is this one here. So if I just run that, let's do that in the positive direction, like so. This one seems to work much better. If I do the minus position, you'll see that that end stop connects and it says end stop triggering stopping motion, so we get that nice effect there. So I'm just going to move that one back again, so about there, and then let's now go to my test homing. So again, I've got my pen up, pen down, I've put in the stepper motor. I'll show you the full code on here. We've got our stepper motors, we've got the pins that they're connected to. I've even provided a parameter for how quickly do we want these to move. That delay US 1500 still seems to be the reliable speed. We're setting the mode to be full rather than half for the steps. The pins need to be 12 and 16. I think that's right, isn't it? Let me just go back to that end stop. 12 and 16, yep. We don't want to run that with the wrong pins. And then the direction of the end stops. So I think it's 1 and -1 for those. And then we're saying for steps in the range of 0 to 800, just move in a particular direction. And on this one I was just seeing if the could make the pen go up and down as well, but I'm going to actually just comment that out for now on this one. We don't need it to do that. I simply just wanted it to move, and when it finds the end stops, it should automatically stop, and therefore this would home the robot. So just need to stop that because one of them is going in the wrong direction. I think it was the Y. Nope, both of them are going in the wrong direction now, so that needs to be like this. Okay, there we go. Right. So that's stopped. And I'm not sure why this other one didn't move then. Let's just try running that again. Have I got the wrong pin there? So 12 and 16. I would have thought that would work. 4, 5, 6, 7, that's correct. So let's comment out the X. We know the X is working okay. So is the Y being triggered as well? Let me just have a quick look on the bottom of that page there. So it thinks the end stop is being triggered there. So if I change the direction of that, yeah, it can still push that out. So if I do the negative direction, so it seems to think that the pin, even if the pins come loose, let me just move that. So that is the right pin on there. Just checking my wiring on there. So I'm not sure why that stopped working. That should work actually. So the Y is in the Y direction, -1, moving one step at a time. Maybe have I got these the right way round? I think we might have these the wrong way round actually. Let's try that. So it should be 12 and 16 is what I think. Yeah, so for some reason it thinks that that pin is being triggered, which it isn't. So that's the pin number. There's the bottom one that's on there. Let's just run our end stop test program. Let's see if when I press this. Yeah, so it is reading that as being pressed in. I think I might have the wrong thing selected there. Okay, let's just go back over there. I just wanted to show you homing it because it's quite nice that it does that automatically. Right, I'm going to go back to my original G code, and I'm just going to check and see what I've got set up on there, just in case there's anything any different, because this does work. So I've got 15 and 16, not 12. That might be why. So let me try 15. And then let's just switch those around again. Right, it's working now. So I was using the wrong end stop pins. Right, so this is now going to click there. Right, okay, cool. So if I move both of these, let me uncomment out that. Let's move these in kind of opposite directions for a little bit. Okay, and we're going to stop it there, and then I'm going to flip the direction of both of these, and then hopefully it will now home. It'll find both of the end stops and stop moving. Perfect, there we go. So we've homed it. So I must have been playing around with different end stop pins when I was setting this up previously. Great, that's good. So the next thing then is this test USB code that I've got. This is quite a big program. This is where all the G-code interpretation comes in. So we've got things like switching off the REPL in MicroPython on USB, so OS dupe term none and 0 will do that. We're setting up our G-code interpreter, which is a piece of code over here. Setting up the steps per millimeter, we looked at that last week, so about 1,000 steps is about 9 centimeters worth of travel, so that's about 11 millimeters per step. I think it's 11.111 reoccurring. And then the G-code steps per millimeter is therefore going to just be passed in there. We can pass that as a changeable parameter. And then we can ignore these Gerbil settings. This is just something that some of the things like CNC.js require to work. They need some code being passed there. We've then got this kind of state, and timer. This was more to do with the Universal G-code sender, UGS. That was like really fussy about having the banner being sent. CNC.js, which we're going to use on this, doesn't really care about that at all. So a lot of that code kind of isn't relevant. And these kind of idle request intervals and status intervals were just ways of detecting whether we'd been requested, we've got a new connection or not. So we've no way of detecting through serial whether the serial's been disconnected or reconnected. If this was a UART with DTS, we could do that, but the way that MicroPython uses the built-in USB chip, we can't do that off the bat. I think CircuitPython you can, but you can't on this one. This poller is because we want to send and receive text from CNC.js or Universal G-code sender without any kind of interrupts. If you have this where there's like a MicroPython's doing some other stuff and it isn't responding to this terminal, the UGS can certainly say that it's pause communication because it's not getting instant feedback. So this poller is a way that we can see if there's any inputs and we can poll that in the background. And we've got this send status. This will simply just output what the current position is of the X, Y, and the pen, the Z. We can send the banner. Again, that's something that UGS requires. It just says Gerbil 1.1F. Press $, for help, and then it passes in some fake position information. We could actually set that to be the real position, and it just says do $H to and $X to unlock. $H is how you home something. We'll try that in our code in a minute. And then we've got these banner sent, and last time, again, that's just we need to send that banner for UGS. It needs to know that, and then we just sleep for a second, and then we've got our main loop. So we're going to grab what the current time is. We're going to send the banner. Again, that's more for UGS. We're going to check for any incoming data. If there is any, we can then read that in using line sys.standardin readline. That's a bit like input if you're using regular MicroPython, but because we're doing this over a USB UART connection, we have to use this system standard in. We have to strip out the returns and the new lines, which is what /r and /n is. If there's nothing in line, then we can say continue. Continue is when you're in a loop, like a while loop. It basically says stop at this point and go right back to begin and then carry on from the very top. So that's what that means there. So there's nothing in the line. Don't do anything. Start again. If the line equals question mark, this is what UGS and CNC.js frequently ask the plotter line, and it just says give me what your current status is. So we can provide these question counters of just how many times has that question mark been sent. And again, if it's been sent more than twice, we just resend the banner. And if we've sent the banner, then we can just update the status that we just sent that through. This /x18 is Control and X. That's quite a common serial terminal type command, and it just means like cancel whatever you're doing. and that'll just resend. Just say set the banner to false and the question mark counter to 0. If the banner has not been sent and the line starts with $, then we send the banner. So that $, is again a way of communication between CNC.js, the G-code sender, and our firmware. If we get the $I, we send the version information. So this is MicroPython Gerbil 1.1. We could put anything on here, Kev's Robots, Gerbil, whatever. We say optional MicroPython USB 3-axis, and then OK. OK is quite an important message, status message, because that means this is the end of this communication. So we have to send OK quite a lot. If we have a $X, that means unlock. So we've not actually put any code in here to lock the plotter in position, and you have to send in you have to toggle with a $X to unlock it. So some plotters, some laser cutters, for example, anything that can hurt a human being tends to have like a lock and an unlock command. But this is a 3D printed plotter. It's not really going to hurt anyone too much. If we have $, then that one basically says, give me all your Gerbil settings. So we've got that Gerbil settings list that we can send out. If we have anything that starts with a G, a question mark G, or a question mark G, then we can respond to that. So G90 means use absolute positioning. G91 means relative positioning. And what this means to our code is, do we take off the previous value, or do we just move with the value that we've been given in the G code? So that's what this G1 and G90 and G91 mean. And we've got a little variable within our G code interpreter that's called relative mode, so we can set that on or off. So that's that. If it starts with 92, that's like set the position. So we've got that. And if it starts with a J, this is like jog. So this means move the position of the gantry of the pen, but don't actually update the position, just move it. And that's so that you can jog it along in case you got into a situation where you don't have to home it, for example. So that's just updating the moving the pen around in effect. The $H is our homing thing, so we can do while motor X is end stop triggered. That's a little thing that will tell me if that button is pressed or not. So if it's not been pressed, then we move it one step in the negative direction. We can move it slowly until X has found that homing position, and then we do the Y. You could combine these together to have it move at the same time, but I've actually observed 3D printers, my Creality 3D printers, and also my laser cutter, they move in one axis and then the other when they're homing, so that's quite a common way of doing it. And then we simply got these message outs just to say that it's moving X or Y. We then stop both the motors on there because they don't need to have, if these lights are lit up, that means that there's energy going to the coils. We don't need energy going to the coil once it's finished moving. And then we can set the position just to 0, 0 once we've homed, and we can output OK. Otherwise, we could just parse the line, and the parsing of the line is, are we moving or X and Y in a positive or negative direction? Get any errors, we just simply write those out as well. So that is our code. We can run this now actually in here. So I'm just going to move this up a little bit. So you can see there we're setting it to full sequence on all three of the stepper motors. And although it's not showing anything here, it's waiting for a command. So if I do, for example, $I, that will give me all the information. So I'll move this up a little bit so you can see it. Oops, like so. So you can see there's like lots of information that's come through there. If I do question mark, that will give you that idle position wherever it is currently, and it'll give you a few of those. I think it does it every second or so. Now if I want to home this, I do $H, and that will home the robot. The robot is actually homed already, so I could now do a G. Let me pull up the code on my other window over here. So if I do G, which is like go 1, can you actually see what I'm typing here? I'm just going to move this up a little bit so you can see the very bottom of the terminal. There we go. Right, so G1 is move and then we pass in an X, a Y, and potentially a Z position. So if we say move X, let's go 10, and move Y 10, we'll see that it's moved. Now, one of them needs to move in a negative direction. I think it was the X. If I do G1 X minus 10, so I think it's actually the Y, G1 Y minus 10, there we go, G1 X 10, you can see there, we can move this around. So what I'm going to try and do is draw, you can see where I've tested this out, a little square. So let's home our robot first of all. So we do $H to home it. So there we go. So it's homed. And if I now do G1 and I do Z, let's move the pen down. So let's do minus 10. There we go. The pen's down. Maybe 10 was a bit extreme. I don't think I needed it quite that far, because it's actually gone a bit of an angle. It's kind of like at that angle rather than being straight down. So let's just move that bit back a little bit. So Z, let's move 5. Oops, that's totally the wrong direction. Let's go G1 Z minus 5. Oh, it's gone totally the wrong direction now. What I'm going to do, I'm going to stop my code for a second. I'm going to use my pen up code just to reposition that pen. There we go, like so. And then I'm going to move that pen down. So I'm just going to jog my pen a little bit. So I think it needs to go down a little bit more. Let's make it go down 15. Right, that looks good. So if I now drew pen up, just updating my code here, you just can't see it off screen. Right, so I'm going to move the pen up. Right. So the first thing I want to do, now we've homed the robot, let's run our USB code again. The first thing we want to do to draw the square is we want to put the pen down. So that's why we're doing this G1 Z. Let's do Z1. Let's do G1 Z minus 1. There we go. G1 Z minus 1. Pen is now totally down and making contact with paper, which is good. Right, so I now want to make the robot move in the Y position, and I want that to go positive 10, I think. So if I do G1 Y 10, no, it must be the other way, G1 Y minus 10. So it's moved the pen that way. G1 X 10. Yep. And if I go to that camera there, you can kind of see that it started to draw the first part of our square. Right, so we now need to do G1 and let's do Y 10, and then let's do G1 X minus 10. There we go, we've actually just drawn a square. You see there? Got a tiny little square drawn. And we did that manually. So let me show you what G-code looks like. So if I now go over to Fusion 360, no, not Fusion 360, VS Code even. VS Code, right. So I'm over here, that's my Kes robot code. Let's go to this one here, which is called Square. Here we go. Let me just zoom in a little bit on that so you can see that a little bit easier. So it's just that. Let's close that out. So this is generated from, I think this was ChatGPT actually gave me most of this code. So G21 says set the units to millimeters. Our code actually doesn't do anything other than millimeters anyway, so that would just get ignored by our code, to be honest. G90 is use absolute positioning. Our code can switch between absolute and relative positioning, but I don't think that's working correctly at the moment. We'll try running this code in a minute with CNCJS to draw that same square that we've just drawn, but we'll see if it actually works or not, because I don't think it's quite right yet. $H homes the robot. G1 means move X to 0, Y to 0, feed rate 500. So this is like start from the top left. When we've homed it, we're already in that position, so that's kind of, it doesn't do anything, that one there. G1 Z-1 will lower the pen. So I've simply changed the Z to interpret it as being, if you provide a 1, then it'll lift the pen up. If you provide a -1, it'll move the pen down. So that will actually, it will ignore the feed rate. So Z-1 will make the pen go onto the paper. Once we've done that, we want to then draw the square. So we want to say G1 to move it. We want to make the X go 10 positions, so move to the top right position. We're providing Y0. We don't even have to provide a Y if we're not actually moving it at all. We then say G1 X10 Y10, so that'll move it kind of down. Then we want to move X0 and Y10, so that'll move it across, and then we want to go back to the origin point back up. So these are relative positions rather than absolute positions, I think. Oh no, these are absolute positions, not relative. And I think my robot works off relative positions, so that's probably not going to work well with our code. But we can actually look at what we've just typed in and update this code to see whether that will work. So if I go back over here and I quickly make a note of what I've written, I'm actually going to update on my other monitor this code. Let's see if I can do that. No, of course I can't do that. Let me just write it down on here anyway. So the first thing we did was Z-1 to make the pen go down. Then we did Y -10. Then we did X10. Then an Y10. And then we did X -10. And then the last thing we should have done was a Z. Let's actually just do that Z. So if we do G1 Z and then 1, I think it is, to move it up. So if I go to that code there we go, pens move back up, perfect. So I've just made a note of all that on another window, so let's update our square code. So I just open this in Thonny, and let me just put this on the screen so you can see it. So we don't need that set. We can use, it's really we're using relative positioning is what we're actually using. So relative positioning, we're going to home it. We don't really need to move it because it's already going to be in that position. We want to move the pen down. So that's the Z-1. Then to draw the square, so we want to do Y. So let's do that. Y 10, is it -10? Then we want to do X10. Then we want to do Y10. And then we want to do X -10. And then finally we want to move that up. Right, so if I save that, in theory, if I now connect this and I use CNCJS, which I've got loaded up here. So CNCJS is G-code sending software. If I now connect to, I have to press this little open button here, just to make sure everything's connected up. There we go. So this is our console. If I do, for example, $I, sometimes this, it seems to put this question mark in front of everything. I'm not sure why that is. If I do 2 question marks, maybe if I do $H, let's see if that will home it. So let's try $H like that, homing the robot. I think the robot is already homed at the moment, so that's good, that's finished. And now we can actually open up in here the G code that we've just written. Let's see if it'll accept this. There we go. So it's kind of drawing in minus positions, but it works, it works. We can also use these jog buttons. So if I go over to here And I'm going to press this move X plus or X minus. There we go. Let's try X plus. You see we're moving ever so slightly. You can see the stepper motor driver lights flashing there, and I can also move this back as well, and we're homed. There is a homing button at the very top of up here. We can press that homing button. That sent that homing command, and it has homed it, so we are now in the right position. Now if I press play on here, in theory it should draw a square. So let's just move to another area of the paper where we've got nothing drawn already. Right, let me press play. Let's see what happens. We did it! That is the actual first run. I've never actually done this before on here. I think the last command where it should have lifted the pen up, I think it went and turned it underneath instead. So that's the only thing I need to change on there. So let me just update that in Thonny. Oops. In Thonny, not on Slack. Let me just quit that. So it should have been that. That's the only thing we did wrong there. So all I need to do on here is just do a G1 Z1 and then G1 Z1 again. There we go, so it's lifted it up. Right, because that works so well, I'm going to run that again. I'm going to draw another square. So let's just press run. Yeah, so I think I needed to basically browse that. I didn't upload the code again, that's what I didn't do. Let's just do that again. And then it's just G1, Z1, G1, Z1 again. There we go. Right. Let's run it one more time. Let's see if that works better this time. Perfect. Now, it's not perfect. That one did wiggle a little bit. Let's try that again. So there is a bit of... This isn't held tight to the paper, so I'm just going to hold it with my hand and see if we can get that to draw a much better square. There we go. Right, now that's working. In theory, we should be able to upload other code. The only problem is I hand-coded this to work with relative positions, and I think what I will probably need to do is update my code so that it can work with absolute positions, not just relative. So there was another piece of G code, which I think if I go to downloads and is it this one? Nope, it's not that one. It is that CNC plotter one. There's this the ABC hatched thing. I don't think that's going to work, and I don't think that's going to work. If I just home my robot, pressing the homing button up here, so it thinks it's homed, and if I press play, I don't think this is going to work. But let's see what actually is going on here. Yeah, so it's really just not happy, and it's just turning the pen over and over and over. So that's not right. So I think what I need to do there is kind of update this code so that it would work correctly. It isn't actually moving the X and Y properly either, and I'm not sure what's going on there. So that's the next step, is to be able to import. We just do a G1 Z1, G1 Z1. Come on, G1 Z1. There we go. There we go. That's better. Yeah, that's the only thing I need to do next. Is basically to update my code so that it can work with anybody's G code and not just handwritten G code that I've written myself. There we go. So that's cool. We've drawn something. We've drawn squares. I mean, they're quite accurate, some of them, when I held the paper still. So that's something we'll need to work on, is attaching the actual plotter to something that can hold paper in place firmly as well. But actually, the X and Y slop isn't too bad. I was worried that this would. You can see there's a little bit of play there, that would affect it a little bit, but not a problem. So what I'm going to do as well is I need to put a lid back on that pen at some point so that it doesn't dry that one out too. So that's really cool. We got it to work with CNCJS. CNCJS took in some code, albeit stuff I've handwritten, but it did draw it and it did tell our code to actually work. So we've very, very, very nearly got our plotter working, as I would say, perfectly. I might put an extra stepper motor micro switch on the pen so that it can home the pen as well. That might be something I do, and maybe if we do that, we can actually set a limit to how far round that pen can go, so we don't get it sort of turning over and, you know, snapping the thing to pieces. Cool. So pleased that we got that working. Right, so I'm going to go back to my slides, and where were we up to? Sorry, because I've jumped out of that, it's messed up a little bit. Right, there we go, we're on there. You're not supposed to see the slides like that, that's the behind the curtain stuff. Right, so why is it now not playing that? I have had this happen before with Keynote. I'm just gonna quit Keynote for a second and then reload that. There's only a couple of things to go. So pleased that it drew that that square. Can't express to you how happy I am with that. That's really cool that it did that. Okay, let's go to that one there, and then let's press play on that. Cool. And let me just find the right place where I was. There we go. Right. Okay. Cool. So that was the demo that I wanted to show you, that it's actually working. We've not got the short circuits, and it can actually draw stuff now, which is really cool. So if you want to join our Discord community, we have a really vibrant Discord community. I should probably spend more time in there, but I spend most of the time just writing code or building or failing to build stuff and learning from it. It's been a week of learning stuff this week, particularly. I think I've damaged 2 of these stepper motors by crushing them with the mole grips. I'm not sure exactly what that will have done. We could probably find out, but yeah, I could see that the short circuit was you know, really affecting how that pen would work, as well as the mechanism just being crushed. You could see the little gear, these tiny little plastic gears. I've got like the tiniest little teeth on them, and it doesn't take much to sort of thread them. You can't see them too well there because the studio lights are so bright, but they're really small, so it doesn't take much to crush them. Anyway, you can definitely share advice, and it was Martin who shared the advice about the half versus the full steps. I didn't know that until he mentioned that. I thought that's just how you made stepper motors work, so I learnt something that week as well. Always make notes of things you learn, and therefore you don't lose the information. If you want to follow me on social media, I'm on all the social medias. So I'm on Threads at Kevin McAleer at threads.net. I'm on TikTok at Kevin McAleer6. I'm on Instagram at Kevin McAleer. On X, I'm at KevsMac. On Mastodon, I'm on at KevsMac at mastodon.social, and I'm also on Blue Sky at kevsmac.bsky.social as well. If you're on any of those platforms, definitely say hi and let me know what you're working on. Really enjoy seeing what people are building. And if you want to join me as well, you can buy me a one-off coffee if you enjoy the content of today's show. You enjoy the 60 hours worth of effort that I put in to draw some little squares, then you can certainly buy me a coffee by going to kevsrobots.com/coffee. If you want to do that on a regular basis, there is the Buy Me a Coffee membership program, and you can essentially do that every month, or you can go to the YouTube membership program, and you can click on that to join every month. And there's a whole bunch of people who've already done that, so let's give a shout out to my supporters right now. So over here on the left side we have Marie. She bought me 3 coffees, I think about 3 weeks ago. Somebody else who wanted to be anonymous bought me a coffee as well. Thank you for that. We've then got the anonymous person. We've got Silicon Fiber, Marie TKD, we've got Jeff Johnson, DN Corty, Marlene Brent and Tom. Hi, I can see quite a few watching the live as well. Then on the YouTube side we've got Justice, we've got Pierre Eves, we've got Ogtrad39, we've got Bert, Marie, Michael, Steve, Ford, Bello, Johnny, Stephen, John Paul, Cassie, Tinkering Rocks, Johnny Bakes, and of course we have Tom. So thank you so much for supporting the show. It means so much that you do that. I can't tell you how much I like it when people subscribe, so definitely consider subscribing. That's completely free. And the spinning logo, that tells me it's this point in the video where YouTube will recommend over here another video for you to watch from their backlog of over 420 odd videos, all been made just for you, for your enjoyment. So yeah, definitely check those out and let me know what you think, and let me know if you're into vibe coding. That's the question of today. So it's at this point in the video I'll say thank you so much for watching, and I shall see you next time. Bye.